Okay, today I'm going to be talking about section 9.2. We're still talking about algebra and linear equations, but now we're applying them to word problems and how to set them up and solve for them. So all the objectives are here if you want to pause and take a look at what we're doing. A couple of specific problems that we're going to look at is distance and mixture problems, which many people have a hard time with. So if you know all of this, but not that, maybe you could just skip to the end. All right, so the first step is identifying the steps to solve a problem. So first, you need to read the problem carefully. And if you have it on paper, I highly recommend, or on your iPad, I highly recommend underlining and highlighting things. Assign a variable to what's being asked. This is really important, assigning a variable to what's being asked. Draw a picture. Write an equation that relates the quantity. So if there's any way to draw a picture of what's going on, draw it. It really helps you. Most people solve the equation and use it to answer the question and include the units in the answer, and then check. Take a look. You might not need to plug it all the way back in. Sometimes you can see that your answer really just doesn't make sense. So take the time to look and see if your answer makes sense in the problem. All right, so the next thing we need to look at is translating sentences into equations. Okay, so when you translate a sentence into an equation, we've looked at these words before towards the beginning of the semester, but remember all of the different words that go with each of the symbols. I'm not going to read through them. Pause the video and really take a moment to look at all of the different words you can use for the different symbols. And now we're going to look at example 1. So let's move on. We're going to translate the sentence into an equation using the variable x, and then we're going to solve the equation. So for the first one, we've got 3 times a number minus 6 is equal to 18. Okay, so we've got 3 times a number, so 3 times, and they want us to use the variable x. So 3 times a number, which is x, minus 6 is equal to 18. So this one's pretty straightforward because it basically just reads left to right. They don't always do that, so you need to be careful. All right, so next they want us to solve for x. What is x? So we're going to add 6 to both sides. And we get 3x equals 24. Then we're going to divide both sides by 3. We're going to give ourselves a little more room here. And we get the 3's divide out, and we get x equals 8. All right, the next one, take a moment to read it. This one is the sum of half a number and 5. So when they say the sum of something, what they mean is you really want to have like those things in parentheses or just in case it's multiplied by something. So the sum of two things is kind of a group. All right, so in this case we don't need the parentheses, but I'm going to do it anyway. The sum, that means add. So the sum of half a number and 5. So half a number means x over 2, or you could say 1/2 x, either one. So half of the number and 5. So that's the sum right here. This is sum. That means equals 0. So now we're going to solve it. So we're going to subtract 5 from both sides. And we get x over 2 equals -5. And now what you need to do is you need to multiply both sides by 2, or 2 over 1, however you want to think of it. The right side, I'm just going to say 2 because it's not a fraction. The 2's are going to cancel out, and I'm going to end up with x equals -5 times 2 is -10. Okay, so x equals -10. All right, the last one, 16 is 4 less than twice a number. So this is where people often get confused because it doesn't go from left to right quite as easily. So 16 is, so I'm going to go ahead and say 16 is, so remember is basically an equal sign. 4 less than, okay, so that means we're going to be subtracting 4 from something. 4 less than. Twice a number means 2 times the number. Okay, so hopefully you saw how I kind of worked through that. I didn't write it totally from left to right. I just thought about where everything was going to go. So now you're going to add 4 to both sides, and I get 20 equals 2x. Now you're going to divide both sides by 2, and the 2's are going to divide out, and you're going to get 10 equals x. And if you're not sure, you can always go up and plug it back in. Okay, so now it's time for you to give this a shot. Repeat example 1 for these 3 problems. So I would really give these a try because just reading them isn't going to tell you whether you know it or not, but trying it and possibly getting it wrong is going to help you to learn it. So pause the video, try it, and then come back and see how you did. Okay, so the first thing we have to think about is how to set up the equations, and that's often the hardest part. The product of 5 and a number is 30. That means we multiply 5 and x, and it equals 30. 9 is 12 more than 3 times a number. So we get 9 is 12 more than 3 times a number. 12 more means add 12. Finding the sum of 11 and twice a number gives -5. Remember, gives means equals. So the sum of means add. 11 plus 2x is -5. And then we're going to solve. And so if you didn't solve correctly, take a look at this. Remember, it doesn't matter which side x is on, as long as it's by itself. Okay, now we're going to look at solving number problems and applications. So the way we're going to do this is we are going to call, these are number problems where they say the sum of 3 consecutive numbers or the sum of 2 consecutive numbers. So you have consecutive numbers being added together. So what we're going to do is we're going to call the smallest number n for number. So n equals smallest. And I would definitely recommend writing this part down. And then n plus 1 is the next number. And then you'll have a place at the end to come write it down and fill it in. And then n plus 2 is the next number. And it is going to be the largest number because there's only 3 of them. Okay? So you would do this no matter how many numbers there are. N is the smallest, n plus 1 is the next, n plus 2. They might say consecutive odd integers, in which case you would have to add 2 because you go up 2 between every odd or even integer. Okay, so it says the sum of these numbers is 81. So that means that these numbers here, they add to 81. So we're going to say n plus, and you don't need parentheses, but I just want to show you that that's the second number. And then this is the third number. And those are all 3 going to add up to 81. So we've got 3 n's, so we get 3n plus, we've got 1 plus 2 is 3. 3n plus 3 equals 81. So we're going to have divide by 3. Nope, we're not going to do that next. Sorry, I'm not going to divide by 3 yet because we've got a plus 3. So we've got to do that first. So we've got to say minus 3 on both sides. And we're going to get 3n equals 78. So now think about what you would do. And we are going to divide both sides by 3. And we get n equals, 3's cancel out, n equals 26. So we're not done yet because we have to say what the 3 numbers are. So that means n, the smallest number, is 26. And I'm going to do that in a different color so that it really stands out later if people come to look. So the smallest number is 26. The next number is 27. And the next number is 28 because we just add 1 each time. So now add those up and see if they really add to 81, and you will find that they do. All right, so why don't you try the sum of 2 consecutive integers is -41. Don't let the negative throw you. You're going to do it exactly the same way. All right, pause the video and then come back and check your answer. Okay, so in this problem, n is the smallest, as usual. N plus 1 is the next consecutive integer. They add to -41. So n plus 1 equals -41. And then you're just going to add up your n's and solve for n. And you should get -21. So that means the smallest number is -21. And the next number, now remember, it's n plus 1 and it's negative. So -21 plus 1 is -20. So be careful with these negative problems. So you add them up, make sure they equal -41, and they do. In example 3, we have a different kind of word problem. It's just comparing 2 different things, figuring out what X is and that kind of thing. So Sierra Leone has one of the highest infant mortality rates in the world at 75. This rate is 15 more than 20 times the rate in Iceland. So now we're supposed to find the infant mortality rate in Iceland. So whatever we're finding, so I'm going to highlight this, find the infant mortality rate in Iceland. That means that is going to be X. Okay, so let's start with that. Let's say X equals rate in Iceland, or Iceland rate, or whatever you want to call it. Okay, so that's the rate in Iceland. Now we need to set something up. So it says 75. This rate is, so that means 75 is 15 more means 15 plus 20 times the Iceland rate. That's the Iceland rate is X. Okay, that's all there is to that. And then you just need to solve. So we're going to say minus 15 on both sides. The 15s divide out, and we end up with 60 equals 20x divided by 20. And 60 divided by 20 is 3. So 3 equals x. So the infant mortality rate in Iceland is 3. All right, so now you give this next one a try. Pause the video and give it a shot, and then come back and see if you got it right. So this problem is probably going to be pretty tricky for some people because it's tricky. But how much did the person weigh is the first thing I want to look for. So x is going to be the previous weight. So you've got to figure out what x is. You can't do these problems without figuring out x first. So after gaining 25 pounds, so that means from their previous weight, they gained 25 pounds. So we get W plus 25. A person is, so is, that means, remember that is means equals. Don't forget that. A person is, they equal 115 pounds lighter. That means less than. That means minus the 115. Then double his previous weight. So here's double the weight over here. So this is double the weight. And this one is 115 pounds lighter. Okay? So you just set all that up and then solve for W. And at the bottom, I wanted to point this out right here. We get negatives on both sides. And then all we have to do, since both sides are negative, that means that the positives also equal each other. Or you can think of it as multiplying both sides by -1. Okay, so if negative W equals negative 140, then W equals 140. Okay, so the next example is distance problems. These are really common kinds of problems. If a person drives on the interstate at 70 miles per hour for 3 hours, the total distance traveled is. So first we want to look at, without even a formula, what we would do with this. So if you think about it, 70 miles per hour means you can write it as mph, like they have on the signs, but that doesn't help us much with canceling things out. So we get 70 miles per hour, or per 1 hour. For 3 hours, so they go for 3 hours. If you multiply those together, you can see that the hours are going to divide out, and you end up with 210 miles. So what we just did is we derived the formula. So the formula, we got distance equals, and we have the velocity or the speed or the rate times the time. So in general, the formula is D equals rate times time. Another way to think of rate is speed or velocity. Okay, rate, speed, velocity, those all mean the same thing. And just, you have to make sure everything's in the same unit. So if the rate is in seconds, then the time needs to be in seconds. And if it's in hours, time needs to be in hours. Okay, so let's look at an example. Okay, so our example is a person drives for 2 hours and 30 minutes at a constant speed, and they go 180 miles. So we're supposed to find their speed. So again, I would highly recommend highlighting or something so that you've got that. The other thing I would recommend doing is writing down the formula. So we've got D equals rate times time, and circle or highlight the thing that you're looking for. So you're finding their speed. So this is the thing that we're looking for. You can go ahead and rearrange the formula so that you divide both sides by T and get R equals D over T if you want to. So, and then you would just plug everything in. And so I can probably do this both ways. And that way you can see it both ways. So what we also want to do is we want to say, okay, well, T equals, D equals, T equals, and R equals. So D equals 180 miles. T equals 2 hours and 30 minutes. So we don't want to combine units. So we're going to say 30 minutes is a half an hour. So 2.5 hours. Now make sure you convert it all into one time. And then the rate is the question mark. Okay, so I'll just plug it into the original equation first. We get 180 equals R times T, which is 2.5. Then we would divide both sides by 2.5, and that would give us R. So then we get R equals 180 divided by 2.5 is going to be 72, and it's a rate, so it's miles per hour. The other way to think about it is like I showed you down here, is to go ahead and rearrange it and then plug everything in. 180 miles per 2.5 hours, which is exactly what you did up above. So these two are the same thing. So either way you're going to find the right answer, whether you rearrange it first or after you plug in the numbers. So now you try this one, pause the video and give this a shot, and then come back and take a look at your answer. Okay, so I showed you how to set this up over here, which again, I highly recommend doing. The people who don't do it often miss these problems. D, R, and T are what we're dealing with because our formula is D equals RT. So we want to lay them all out, put a question mark next to the one that we're looking for, and that is the speed that I have highlighted over here. So D is 24 miles, and T is 1 20/60 of an hour. So you could put that in your calculator and get 0.33333, but you won't get an exact answer unless you use lots of digits. So a better way to do it is just to leave it as a fraction. So that's 1 1/3 or 4/3 hour. So you can just put 4/3 in right here. Or you can use a calculator and keep all of the digits when you divide 20 divided by 60. And you should get 18. Okay, so this next question is a little complicated, and it really helps to make a picture. So I've started with a little bit of a picture and also our formula, because this is a speed problem. So an athlete jogs at 2 speeds. So right there I stop and write down D equals RT. D equals R times T. So they cover a distance of 7 miles in 3/4 of an hour, but they run at 2 different speeds. So for the first quarter hour, they go 8 miles per hour. So we're supposed to find the second speed. So let's fill in some things here. So the whole distance is 7 miles, and they do it in 3/4 of an hour. Okay, so 7 miles is the full distance, and we know they've run that whole distance. So we know the total distance, D, and I'll put it in green because that's what I've got here, and this whole long thing is going to be D. D is 7. Okay, so the distance is 7. But we've got 2 different rates, but there's going to be a distance here. We don't know what the distance is, but if you think about it, the distance in blue right here, this distance, equals or plus the distance in red. So this distance is going to equal 7. So the distance in green equals the distance in blue plus the distance in red. All right, so now let's think about what they did here. They ran a quarter hour at 8 miles per hour. Okay, so I'm going to fill that in right here. So 1/4 hour at 8 miles. I'm just going to put mph, even though it's miles over hours. 1/4 hour at 8 miles per hour. We don't know how fast they ran the other half. That's what we're looking for. But we do know how far they went. I'm sorry, we do know how long they went. So the one thing we know here is that the total that they ran was 3/4 of an hour or 45 minutes. So let's look at how long they ran here in terms of time. Okay, so the time they ran here. So think about that. You've got 3/4 hour minus 1/4 hour. So what's left is they ran for a half an hour at this speed. So we know everything except for the rate here. We don't know the rate, so that's the one thing that's missing. So we're going to set this up as the distance is rate times time in blue plus rate times time in red. That's the longer distance that they ran, and that is going to equal 7. All right, so we know the rate that they ran in the blue part. So that's going to be 8 miles per hour. So we've got 8 miles per hour times the time is 1/4 of an hour, plus the rate they ran in red, we don't know. That's the one thing that's missing. Times the time that they ran, which was a half hour. Because remember, a half and a quarter need to equal the 3/4 hours that they ran. All right, so let's solve this. All right, I just had to move this up to give us a little bit more room, but we've got 7 equals 8 times 1/4, or 1/4 of 8, or 8 over 4 is 2, plus r over 2, or r times 1/2, however you want to think about that. I like to have it a little more tidy so there's less things to look at, so I usually put them together. So we're going to subtract 2 from both sides, and we get 5 equals r over 2, multiply both sides by 2, and we get r equals 10. So what were we looking for? We were looking at the rate, so that's going to be 10 miles per hour. So the jogger ran 10 miles per hour in that last half hour. Okay, so now it's time for you to give it a try. A car travels at 2 speeds, the total distance of 28 miles in 5/8 hours. So remember to draw a line just for the total distance. And then they traveled 3/8 of an hour at 32 miles per hour, and then we need to find the second speed. So pause the video and give that a try by yourself, and then I'll have the answer up here when you come back. Okay, so we've got 3 different things happening here. We've got the total distance and time. We've got the speed for part of the time, and then we don't know the rest. So you can find the rest of the time in red here by subtracting the 5/8 total time minus the 3/8 time in the first portion. And you get 2/8 of an hour, which is 1/4 of an hour. Then I came down here and said, well, the distance total in green is going to equal the distance in blue plus the distance in red. 28 is r times t plus r times t. And then you just plug everything in and leave the unknown rate or speed out, and then solve. I ran out of room, so I came up here and continued on. I multiplied both sides by 4, and the 4's canceled out right here, and you end up with r equals 64 miles per hour. Okay, this next section out of 9.2 is solving mixture problems. So this is a solution contains 4% salt, so it's just some solution with water and salt in it. How much pure water should be added to 30 ounces of this solution to dilute it to a 1.5% solution? So it starts out at 4%, it goes down to 1.5% by adding water. You can't really take the salt out to make it less, you have to add water. So think about what this is going to look like, and I have a picture here that we can look at. So what we've got is 3 different solutions, basically. We've got water, which we want to know how much we're going to add. So when we add the water to a 4% solution, we're going to get a 1.5% solution. So what we want to know is if we have X ounces of water and we have 30 ounces of this 4% solution, we're going to end up with, now here's the key that isn't given in the problem, but you really need to consider this, that X plus 30 is how much you're left with when you add them together. So you add X to 30, you get 30 plus X, or X plus 30. Okay, so there's some ways that we can look at this, and the best way to look at it is in a table, and then from the table we'll set up some equations. So I'm going to bring the table up for us to look at, and we're going to fill it out together. All right, so first we have, for these kind of problems, the first thing you want to do is draw some sort of a picture and figure out what X is. So in this case, X is the amount of water, okay? So we're going to come over here and say X ounces of water, just pure water. And this is our solution, okay? So this is what we're calling the solution, and I'm going to abbreviate it SOL''N. And this is our new solution over here. All right, so that's diluted solution. So this is initial, and this is diluted solution. All right, diluted. All right, so the pure water concentration. So first we're going to look at the concentration of each of these 3 things, and then we're going to look at the amount of solution, and then we're going to look at the amount of salt. And so the first thing you should always do is decide what X equals and draw a picture. Draw a picture. Number 2, you need to understand that the amount of salt, or whatever it is that you're diluting, is equal in both situations, from the before and the after. So that the amount of salt in each of these 2 beakers here, so the salt here, equals the salt here. Okay? It doesn't change. All we do is add water. So the amount of salt in the container is equal. That is very key to understanding all of this. So pure water, the concentration of salt then is 0%. We need to write this as a rate, so it's 0.00. That one's pretty easy. And then the initial solution was 4%. So 4%, we need to write that as a rate. So that's 0.04. The diluted solution is 1.5%. So it's going to have less salt per milliliter or per ounce. 1.5%. And so that is 0.015. Make sure you don't make it 0.15 because that's 15%. All right. Our solution amount, and this is going to be in ounces. Okay. The solution amount in ounces is going to be X for the pure water. That's the thing we don't know. And the initial solution is 30. So think about what the solution amount for the diluted is. We just wrote it up here, and that is X plus 30. All right, so then the salt in the first one is 0. All right, there's no salt in the first one. In the initial solution, it's going to be the same in these 2, but we've got to figure out from what we're given how to set them equal to each other. So in the initial solution, the salt, and this is key to understand, is we're going to say, well, it's 4% salt. So this is our part, 0.04, and that's our rate. So 0.04 times 30. That's the whole. Okay, so part times whole, percent times whole. I shouldn't have said part, I meant percent. 0.04 is our percent. Percent of the whole equals the part. So that is going to be 1.2, and this is also in ounces. I really don't like English units because metrics makes more sense because we have 2 different kinds of ounces. But anyway, 1.2 ounces of salt. Okay, it says that up here, but I want to make sure that's really clear. So now we're going to have, in this case, we've got 0.015 here, and we've got X plus 30 here. So to find the amount of salt, we're going to take the percent 0.015 as a rate of X plus 30 is going to give us the amount of salt in our final solution, which is, of course, the same. So those 2 are the same. So now we're going to set up an equation that is 0.04 times, well, I don't even have to do that. Let me undo that because basically it's the first thing we did. It is the 1.2 ounces. That is 0.04 times 30. So we're just going to use the 1.2. And we have the salt here are both equal. So these 2 are equal to each other. And we're going to set them equal to each other. So I'm going to put the X on the left because that's what people are used to working with. So we got 0.015 times X plus 30, amount of salt in the final solution, equals 1.2 ounces of salt, which is how much we figured out we had in the 4% solution. So again, it doesn't change. So now we're going to just do this algebra problem, which is pretty straightforward as long as you're careful. So we get 0.015 times X plus, now remember we're distributing this times this and then this times this. So 0.015 times 30 is 0.45. You can just use your calculator, equals 1.2. So now we're going to subtract 0.45 from both sides. And we get 0.015 equals, now this is subtracted out, 0.75. Oops, I forgot the X. 0.015x equals 0.075. Now we're going to divide both sides by 0.015. It's going to divide out, and we are left with X equals 50. All right, 50 what? Well, we were looking for ounces of water. So it's going to be ounces of water is how much we need to add to that solution to get the mixture to dilute to 1.5%. Okay, so now I have an opportunity for you to try this problem when you can see the answer right after trying it. Please do try it because these problems are pretty hard and you want to have a chance to give it a shot. So pause the video and try. Okay, for this one, for the first time, I'm going to actually give you little steps along the way to make sure you've got it as we go. So the first thing you need to do is draw your picture, and you have this solution of water, which is just water. It's not a solution, so there's some water in here. And we've got 1,500 milliliters of a vinegar solution that's 15%. And we want to know how much we're going to add to this to get a 10% solution. So we start with X milliliters of water, 1,500 milliliters of 15% solution, and our final amount is going to have X plus 1,500 milliliters of a 10% solution. So remember, the amount of vinegar, so the vinegar to start in the solution, so the initial vinegar is going to equal the final vinegar. That part doesn't change. We're just adding water. It's hard to talk and write at the same time. So now we want to stop and think about what are we going to write over here, and then what are we going to set equal. So I'm going to pause again and let you try that. Okay, so here's our next step. The amount of vinegar is going to be the percent times the solution amount. So the percent of the whole equals the part, which the part is vinegar. So of course this one is just 0. But then for the initial solution we have, because that's water, the initial solution is 15%, 0.15 of 1,500 milliliters is going to give you the milliliters of vinegar. And then the diluted solution is going to be 10%, 0.10 of X plus 1,500, the amount of volume that you have when you add the X. So now what are you going to do? I'm pausing. I hope you do too, and try it yourself. Okay, so this last step is just to set these two equal to each other, because the amount of vinegar from the beginning to the end never changes. So we get 0.1 times X plus 1,500 on the left, that's the diluted solution, equals the initial solution. 225 is what we had here. 0.15 times 1,500. So we're going to set all that equal to each other, then just rearrange and solve for X, and we get 750 milliliters of water needs to be added to dilute it to 10%. All right, that's the end of this video, so hopefully that helps you with some of this material.